Welcome to my session. My name is Gaurav Saxena. I work for one of the largest automotive companies in US. My talk is about internal developer platforms, CI/CD, and OpenFeature, of course, because we're in the OpenFeature Summit. But I will be, in next 20 minutes, I will cover a lot of ground to talk about various CNC of projects, of course, keeping OpenFeature at the center and foremost. But before I go and talk about OpenFeature specifically, I need to set the context how we do our platform engineering practice, and then how various ecosystems of CNC of projects come into play, and then how we are using today OpenFeature specifically to power all the workflows. For a quick context, automotive industry is quickly moving towards software-defined vehicles. What that means, it means that we have a high volume of data that we ingest from vehicles to cloud for various use cases like predictive maintenance. And then we power the OTA workflow from cloud to device. There is a research by Forrester and Gartner, I think one of them or both of them, which says that by 2032, there will be 100 million of vehicles connected to the cloud platform, and the subscription revenue is 30% year over year, the growth. And why it is important? The reason it's important because at enterprise companies like the scale, you want to create a central operations team, a centralized platform that can take away the developers' concerns so that they can focus on the business logic, and your platform team focuses on providing the end value, which could be, in this case, let's say, for example, your CI/CD pipelines, your observability, your messaging infrastructure, your database infrastructure. At the end, you do not want your developers to know all the internals of Kubernetes. You want developers to focus on the logic that moves the needle of the company, while platform teams focus on the needs of the developers. I'll go with the preface. I have worked for startups, and this is kind of resonates with my life story in terms of professional life. This slide will resonate if you are on the startups where, every journey starts with a kind of like a product market fit. You focus on the iteration, and then there is adoption slowly, but operations in these two phases doesn't come into foremost mind. Now, when you have a product and the users love it, then you need to scale. And then where people start focusing on the architecture and the infrastructure. The reason I say that is that I've been on incident calls where there are 100 people on the call, on the bridge, and asking questions like, was there a deployment 20 minutes ago? What caused this incident to happen, right? That basically gives the mandate for organizations to create this centralized platform team. These are the problems that most of people are aware of it. There's a cost of complexity. There's a whole silo effect. Each applications team are doing their own best practices. The learnings do not transfer from one team to the team, right? Silo effect. And then there is how many teams are doing the whole patching of their vulnerabilities and the CI/CD pipelines, right? That doesn't make sense in terms of like having those teams do it. Let the platform team handle that workload. I'll just give a quick synopsis of what IDP is. Think this as like a control plane, your Kubernetes as a first-class, API-driven, right? So you can have the control plane. Today, most organizations uses Kubernetes as the container orchestration and management. You can have the same control plane manage the hyperscaler resources like your AWS and GCP. You can also have it manage your databases. So we use a CNC of graduated project recently called Crossplane, which actually does the infrastructure, the build-up. So basically, it can reconcile the whole your desired state as well as your actual state, just like the Terraform does. But basically it's a Kubernetes-driven, so there is less problem in terms of a drift away from the policies. You want to build the security baked into this platform, so you have a whole pipelines, secret management. and like a user interface that could be like a backstage that an end user can interact with your platform to know the state of the infrastructure. So this is basically the platform engineering slide here. The best practices that I have come in terms of my own experience working with this. So basically, we provide standardized failover and recovery. So if your applications need to be deployed in multi-regions, how does the platform team enable that workflow? Standardized observability, security governance, and of course, incident management and process. This is a project spec called Open Application Model. Kubevela is one of the implementation. Basically, you have basically two personas, platform engineer, and then you have application engineers, right? So platform engineers like to think in terms of Kubernetes, config maps, secrets, load balancers, ingress. Now, if I'm an application developer, I should not be thinking about Kubernetes in general. I should not know about Kubernetes. I mean, I can know about Kubernetes, but I should not be constant with in terms of Kubernetes knowledge. So if I'm writing an application, I need a database, I need a messaging system, I need an observability, I need scalar, like things like it needs to scale with your HPA policy whatsoever. So, and of course, on top of that, you have the whole authentication, authorization principles, right? So the OM spec basically defines your components and the traits. So traits are like enable the components. So you could be scalars, could be your policies like I want to deploy in this region, things like that. Your policies around from security point of view, right? So that's where the Kubevela comes into picture. Think this as like a CRDs where a developer, when they have to write the application, I can, instead of writing the Kubernetes, think of Kubernetes service, pods, ingress, HPA, secret management, I can just specify declaratively, these are my application needs, and the Kubevela spec, or OM spec, the Kubevela implementation will take it and then turn into Kubernetes objects. Now, slowly coming to where the open feature that we are using in today's platform, but before that, I need to talk about CI/CD because that's where our open feature comes into here. This is one of the very basic footprint, but I will describe it in a very cloud-native way because CI/CD, of course, has been solved by the industry, but our take is on the basis of following. So we today do a CI pipeline with the programmable CI pipeline. What I mean by that is that instead of having developers write the Docker files, we take the programmable way of things. There's a open source project called Dagger. So Dagger lets you build CI pipelines in a programmatic way. So you can, like for example, you can bring your hardened base image. If you are a Java app, you can build hardened Java image. And on top of that, you can layer the images on top of that. And then you can have the whole CI SAST scanning tools, like for example, SonarQube, FOSSA scan, if this is my open source, breaking any license, right, packages, its dependencies. You can create the whole SBOM, software bill of materials. You can also have provenance and attestation. So for example, when I'm going to upload that artifact to any Nexus or JFrog, whatever you use, it needs to be cryptographically signed because I want to attest that it came from which commit, which developer, because you don't want to introduce any in between a layer of security attacks, right? So that's our CI pipeline. In terms of a CD pipeline, we have things around image attestation. So for example, if the image has been signed by that particular engineer, that particular GitHub commit, there is an open source project called cosign, 6-store cosign. So we use that, and then on top of that, at the time of deployment, if your image was built 6 months ago, it may have been sitting in your registry, but now there is a CVE because of the research that has happened last 6 months. How do you want to make sure that image does not get deployed, right? Because it should not be deployed if there is a CVE on that. So there's a whole tooling around tools like Kyverno, KubeWarden, all the CNCF projects which we use to define the policies, where it can reject, the admission controller can reject those images and then let it not deploy. Now, I'm going to talk about in the open feature in the context of the CD pipeline. So I talked about the OM spec. I talked about the Kubevela. These are the manifests that gets rendered into Kubernetes objects, right? How did we use that? So our journey didn't start with Kubevela or OM spec. Started with just like having separate teams writing their own Kubernetes specs, services, deployments. But we wanted to make sure that their applications, if they deploy the next time, it should not break, since we are introducing in the workflow the kubevela, right? So basically, you had the legacy way of rolling out the applications to the production, and this is the new way of deploying to the production. So that's where our OpenFeature implementation come into picture. I will say that without naming the vendor here, but the vendor is actually, of course, the OpenFeature compliant. That what we did is that we took and turned their APIs into cross-plane objects. So basically, the same cross-plane, we wrote the whole Kubernetes operator around that, so that operator can deploy the whole project, the OpenFeature compliant project, into our infrastructure. So now the applications team do not have to worry about the whole feature flag management. They just specify in their OM spec, here is my project, here are my requirements. Either I'm using Boolean or JSON, whatever flags they have, they'll mention in a declarative way, and underneath, the infrastructure will take care of it. So that's the kind of the implementation that we have behind the scene, basically, again, providing the developer productivity from that point of view. I mean, this slide is very basic in terms of like everyone knows about the deploy is not equal to release kind of situations. We want to make sure that when you deploy things, you're able to you don't want to release it if you're not ready. You can do the things that are about canary rollouts or A/B testing, all that in all that phases. I kind of talked about this slide already, but basically this is what the process was. We took that OM spec, we turned into Kubernetes object, and we turned it behind the feature flag. And then for each of the components we have, whether it's, we use distributed Postgres, we use messaging solutions like Apache Kafka, Apache Pulsar project. Now, since we converted those into the cross-plane and the applications were done in the kubevela, we turned their next deployments behind the feature flag so that we can have their deployment going around and then checking through the open telemetry, the observability. So basically, we had the whole open telemetry traces injected into all the workflow of CI/CD workflow, making sure that all the traces it's capturing is actually in line with what the expected behavior was from the legacy application point of view. So you have like an apple-to-apple comparison. You're able to find out which phase. And again, with the feature flag management, you can always roll out to 10% of users. So we did all that like in terms of our less critical applications. We had the 10% segmentation and then different identity overrides in OpenFeature to make sure that those population of the services are getting captured for the services that their end users wanted. So we like a comparison between all the environments from dev to staging. We call it here preview, and then the live, which is production basically. So this talks about kubevela to custom OM Hybrid. I just want to leave it as a introductory slide here. Kubevela is great. It is still evolving, but it does serve the need. But our journey started 2.5 years ago, and we were new to kubevela. So basically, what we did was also wrote a custom OM implementation, meaning following the OM spec, but we wrote in terms of Go, our programming language choice is Go, so we basically converted those structs definitions into our custom implementation of kubevela for only one way of doing things, which is the testability. So in kubevela, you have a language called Q, which is not that hard or easy as whichever camp you belong to learn. But Golang is the kind of the language for the platform engineers. You can test your rollout of your different components in a programmatic way. That slide talks about that. So this slide also talks about the behind the feature flag, how we were able to do that between the kubevela and the OM spec. That's all I had in terms of the presentation. Here is the feedback code. I would appreciate the feedback, and I will take any questions from here.